All right, so speed is not too bad. It's just one extra little piece in addition to the rest. So not too bad. You're gonna really feel like you're doing the same thing.
Isaiah Mosier, can you please go to room 116? Isaiah Mosier, please go to room 116. Thank you.
All right, so speed is just the absolute value of velocity, and we've talked about this in the past. This I'm going to start, okay? We can tell if the speed, if you're speeding up, slowing down, if your speed is increasing, if you're speeding up, it's when the signs of V and A are the same. So positive, positive, or negative, negative. Both positive or both negative. The speed is decreasing, slowing down, if the signs of V and A are opposite. So if your velocity is positive, acceleration negative, or velocity is negative, and acceleration is positive. So I was just thinking of these as kind of like when you're multiplying integers. They're the same, speeding up, opposite, slowing down. And we're just going to incorporate that into our everything we've been doing. So it's just one extra little step. So we're going to really start everything the exact same way. Every single problem we start the exact same way. SVA. So I'm just going to write out my S. And my V is the derivative of S, and my A is the derivative of V. Then I do my sign charts. So I set my V equal to 0. You can factor this. You can just solve for t and take the square root. I'll factor out the t, or the 3. Then we just have t plus 1, t minus 1. Up here you could have added 3 divided by 3. T squared equals 1, so t equals plus or minus 1. So you really can get this both ways, whichever way makes better sense. The big thing is, we don't consider time of -1 because time is never negative. So we start with 0, and we only use 1, and we label velocity. Then we're going to do, if I plug in a half, positive, positive, negative. So my velocity is negative between 0 and 1. And after 1, if I plug in 2, it's positive, positive, positive. So it's positive after 1. Then I'm going to set my acceleration equal to 0. And that's when t equals 0. And so I'm going to start at 0, and it never changes acceleration because it's always positive. 6 times a positive is always a positive. So acceleration will always be positive. So that's letter A. All right, letter B. The initial conditions. So I'm just going to come back to my equations. S of 0 is 1. V of 0 is -3. And A of 0 is 0. Hence, using these, describe the motion of the particle. Okay, so the position is positive. So the particle is what's our label? Centimeters? Yep. Is 1 centimeter right of the origin. And it's moving from 0 to 1, moving left at 3 centimeters per second. So -3 just means left at 3 centimeters per second. Since the acceleration is 0, that's all we really need to say for B. All right, C is kind of new, but it's really just the same thing as B, where B is where everything is 0. C, we're just going to find everything at 2. So now plug in 2 into your original function, your position function. You get 3. Really, we should probably be labeling these. Okay. V of 2 is 9 centimeters per second. And A of 2, 12 centimeters per second squared. So now we're going to describe everything at time 2. So I'm going to say at t equals 2 seconds, the particle is 3 centimeters to the right of the origin. It is moving right at a velocity of 9 centimeters per second. And the acceleration is 12. So we can say that the particle is speeding up or increasing speed because V and A are both positive. So we didn't really need to back here because A was 0, so it wasn't either one. But because both of these are positive, we're going to say that the particle's speeding up at time 2. All right. So letter D. So we already found the time at which it changed direction. So now I'm going to come back up here because this is when we found this is when it changed direction. So the position when it changes direction is just S of 1. So if we plug in 1 to our position function, that's just 1 minus 3 plus 1. That's -1 centimeters. So then we're going to do our motion diagram. All right, so this is kind of a hot mess. Let me come down here. Hopefully we can see everything. So E is our motion diagram. I'm going to draw my position function along the bottom. So my initial position is 1. I'm going to change directions. It goes to -1. So I need to put 0. I need to put 1. And I need to put -1. All right. So we begin, our initial position starts at time 0. I start at 1, and it's negative velocity moving left until I get to -1, because at time 1 it changes direction. We just found that position at time 1 is -1, so it turns, and then it's always going to go to the right after time 1. And we can even extend it to match here if we want, because then at time 3 no, at time 2, it's at position 3. We can just kind of incorporate this stuff into the equation. Okay. And letter D, what time is the particle's speed increasing? So this is where both, it's kind of like you want to overlap your sign charts for both velocity and, let me do this down here in the corner. So everything is starting at 0. So at 1, it's negative and positive for V, and it's always positive for A. So for it to be increasing, we want to know when are they both the same. So they're both the same. From 1 to infinity. And that's it.